Thanks for joining me today for this NZ Summit session on driving a test-first strategy with CDK and test-driven development. My name is Nelly Lovchikova, and I'm a solutions architect here at AWS. I am delighted to be here with you to talk about building reliable and well-documented infrastructure. We are in the new era now, when development and ops collided in mighty DevOps, and cloud computing allow us to spin up resources at our wish and then discard when we no longer want them. As a developer, I'm excited to be able to control that power using tools I'm already familiar with, like JavaScript, or my personal preference, TypeScript. Now, let's set a scene. I'm going to talk a little bit about how you can build your infrastructure as a code in AWS environment. AWS Cloud Development Kit, CDK, is a multi-language software development framework for modeling cloud infrastructure as a reusable components. We don't write actual code that is going to create our infrastructure. We write code that models this desired state we want for our infrastructure. And then we pass this state to provisioning engine, such as AWS CloudFormation. And it's going to look at this model and realize this configuration for us. Here on this slide, you can see supported languages. And yay, we have new one coming. And also, you can see example of the code. It is just a normal TypeScript set of statements. And the good news is IntelliSense supported. There are a few concepts you need to know, so my demo looks a little bit more comprehensive. Stack, unit of deployment. All AWS resources defined within the scope of a stack, either directly or indirectly, are provisioned as a single unit. Stack can have multiple constructs or resources. Constructs are the basic building blocks of AWS CDK. A construct represents a cloud component. I like to think about constructs as classes. For example, I'm building static site, so my S3 bucket and CloudFront origin are going to live together in a construct because they're logically linked. Construct will have multiple resources and also can have nested constructs. Resource is a representation of AWS resource. For example, an S3 bucket or a Lambda. Aspects is the way to apply operation to all constructs or resources in a given scope. You can then use it to make changes or validate something. For example, you can use aspects to apply tags to all resources. We introduced the Cloud Development Kit, CDK, in 2018, and it has become very popular. CDK is a technology of choice for many organizations. The power of CDK is flexibility, and also you don't need to learn any new concept. All previous knowledge you had as a developer still relevant. Loops, conditions, classes, components, language syntax, even tooling. If you look at this code, you will notice there isn't anything new there. What does it mean? It means it can become messy and buggy. What else could go wrong? I'll tell you what. It is not something we often talk about, but infrastructure debugging takes a lot of time and quite complicated. You know, to deploy first. Where are you going to deploy? Do you have environment per developer? Or you have development environment, and everybody deploy and test there? How people not to step on each other? And it takes time to deploy and test. So a feedback loop is very, very long. Other problem is documentation. With dynamically changing environment, how you keep track of those changes? We all know software was never perfect. and won't get perfect. But it is not definitely a license to create a bad software. How often have you started a new job, took a look at the code, and immediately wanted to disappear and never see it again? But you already have like few tickets assigned to you? Have you ever been on the other side? When a new engineer joined and you tried to explain your infrastructure code, and you apologize a few times, and when they ask for documentation, you sort of pull up a PDF document that is 2 years old and only slightly resemble the actual state of your workload? And those problems are new. We've already seen them before. But I believe that have a bug-free, clean code for infrastructure is even more important because of the cost of error. And what is the cost of the bug? From my experience, it can be significant. But I have a solution. Let me introduce you to test-driven development. And I'm sure you heard about it. It is an old concept. Ken Beck gave it a name in his book, published in 2002. But you can find traces of it in Dijkstra's The Humble Programmer book, published in 1972. Test-driven development is a set of techniques that encourages simple design and test suites that inspire confidence. By driving development with automated tests and then eliminating duplication, any developer can write reliable, bug-free code no matter what its level of complexity. This is a very important part of the talk. Just hear me out. Any developer, any level of complexity. Isn't it awesome? Moreover, TDD encourages programmers to learn quickly, communicate clearly, and seek out constructive feedback. So if you practice it, it makes you a better developer. Many developers use unit tests and TDD interchangeably, especially during job interview. Let's be clear. Unit test is a piece of code that sets up inputs and validates outputs of a function. Test-driven development, TDD, is a process of designing business logic using unit tests as a drive. Let's look at the other benefits. Number of bugs reduced. Don't trust me on that. There was a white paper published in 2008 by researchers from IBM and Microsoft. The result of these case studies indicate that the pre-release defect density of the 4 products decreased between 40 and 90% relative to similar projects they did not practice TDD. Then, it is a design time observability. What does it mean? It means when tests fail, an error happens, you not only know there's an issue, but you know exactly what happened and what functional expectation is no longer met. And the refactoring is a breeze. You can run your test suite locally, and even before you commit your code, you know nothing is broken. So it removes this anxiety part of software delivery. The last benefit, your code gets shipped with the full set of documentation that described in details how exactly it's supposed to work, and I'm going to demonstrate it. So the process looks like that. Add a test. Run all tests and see the particular test to fail. Very important part. If your test didn't fail, there may be a problem. Then you need to make a test working by implementing the actual feature. Run all tests and observe them all green. Refactor and clean up. Just notice, you first define your expectations, and then you implement them. And also, we first make things work, and then make it clean and elegant. Let's explore that a little bit deeper. So I'm going to demonstrate how that in practice. But before, I need to explain a context. Because test-driven development, TDD, is not a technical practice, but behavioral. And it doesn't make sense without good problem to solve. I'm a big fan of Star Trek, so I'm going to work for Klingons. And they would like to join Federation, and joining means we're going to have extensive communications. Since Klingons are very strict on their heritage, those communications channels need to have certain standards. My job is to build an API component that is going to be used by others in Klingon community to exchange information and trade with the rest of the Federation. I'm going to demonstrate building an API that others in Klingon community are going to use. Some only need the information to flow in one direction, and others need bidirectional communication. And I'm going to split this problem into smaller parts and attack them individually. By defining expectations up front, then making them work, and make code a little bit cleaner. I created CDK project using CDK init command and set a language to a TypeScript and gave it an app name. And here repository for the code I'm going to demonstrate. It is a demo time. This is a newly initiated CDK project. The only thing I did is installed an API gateway library. Also, Jest library is already added and configured for testing. Now I'm going to demonstrate my first test. I like to think about tests as stories. So this story about building bidirectional communication channel. From practical point of view, this channel should allow Federation to submit everything about that new starship they're building. When I write stories, I use behavioral style because it offers very clear framework for story definition. It doesn't describe implementation or UI, but it focuses on a business value. It always starts from defining context. Then it outlines conditions of the situation, and then it states what expected to happen. So first, I define the context, given the communication channel is needed. Then it defines an input, when changes are allowed. And at last, it defines expectation. The requester can create a new record. Notice there aren't any mentions of API, HTTP verbs, or anything, just the business value. Now we can actually set our inputs and outputs in the code. So here an empty stack. As you may remember, it is a unit of deployment and also provides a scope. Then I'm attaching the channel construct to that empty stack. Notice the isRead-only is false, indicating you can create a record. And the last statement, I validate that the output has an API gateway method post. Let's run it. I updated the Jest command to run in a watch mode, so it retests everything on saving every file. What is happening right now? CDK builds the project, creates a memory CloudFormation template, and we are going to validate it. As you can see, tested fail. It doesn't like the channel class because, surprise, we didn't create it. Just pause here and notice how we already know the shape of the component we are going to create. My next step is to make it green. I'm going to check out next branch, and test is going to run again because we configure it just in this way. Notice the test is now green. Let me show you around. I created class channel that is extend construct. As you remember, construct is a component like a container for AWS resources, so we can logically link them. All constructs accept scope, and every single resource or construct created within the scope of a stack. I created an API gateway and added post method. Also, I created channel prop interface for inputs and added into it construct. Since the test is green now, I am confident this first functional expectation is met now. Let's add another one. Switching to branch number 3. There I added one more test. Notice we are still in the same context, but now have different input. In this scenario, we need to make sure the channel may be configured for consumption purpose only. For example, Klingons happy to share their fighting laws, but don't want aliens to change them. So input changes not allowed. And the expectation, user have no ability to create a record. I also made some changes. Because I don't want duplications, I moved stack to a global variable and instantiate new one before each test. Also, the previous test still there and ensures we didn't compromise previous expectation by introducing new code. A new test already run and fail? If you check what is fail, you find the exact scenario. How cool is that? Imagine being new to this part of the code, made a change, and not only see what is failed, but also understand the context and intention. Let's implement that code. Switching to branch number 4 with the last part of this demo. Here, I implemented an input-based decision-making process. Notice I have to add a get method because you cannot really have an API without any methods. If I comment it out, my test is going to fail. And it is really up to you how you want to deal with it. You might want to create another test to ensure everything working as you expected, or you can just sleep with it. What we have done. I demonstrated a test-driven development workflow using Cloud Development Kit. Started from first test, defined my functional expectation, then implemented it, made some refactoring. Repeated again till all requirements converted to tests and all those tests pass. Before teeing of an example to being too simple, spend 15 seconds imagining a world in which all code was this clear and direct, whereas there's no complicated solutions, only apparently complicated problems begging careful thought. Let's have a little bit more complicated example. As an owner of the component, I'm allowing other people to add integrations between API and their part of the business. As I mentioned, Klingons have standards, and I need to check all provided integrations for wildcard permissions. Because I don't want, for example, Lambda integration to be able to create new users. We don't want Federation to create fake Klingons. I'm going to use aspects. If you don't remember, aspects is the way to apply operation to all constructs or resources in a given scope. This cool ability allows us to inspect given collection of resources and do something interesting. I'll show you how. Here again, we have brand new project with installed identity and access management library. Let's write the first test. I'm going to write a little bit different that time. First, I define a context, given that scope is provided. Then define an input when there is an allow policy. And here's the difference. I have a second input and then the last node. You may have more nested content. It is very much depends on your test structure. I'm going to put another test under that context. There is this test implementation. I'm preparing input by creating new stack and attaching new resources, including policy we need to check. Then I apply aspect statement that should inspect my resources. And here, I need to decide what kind of validation I want. And I have a couple options. First, I can expect an exception. And the other is to use native CDK annotations. Annotation is a metadata. Can be just info, warning, error, or deprecating node. If it is an error, you won't be able to synthesize the output file. And I actually don't want an error or exception. I want user of this component to know I'm not happy, but they still can proceed. Unfortunately, I couldn't find right implementation for JustMatcher, so I did it myself and learned something along the way. Here, I declared my JustMatcher globally, and then I implemented it. So first, I synthesized the artifact using CDK utility, and then inspected for warnings. If a warning message matches with provided, then pass it. And here how I use it. Just a note. When I was exploring this functionality, I had about 5 unit tests in order to produce this matcher. I'm not going to demonstrate it. Just wanted to point that every single expectation has to be defined as a test. As you can see, a test is red, and my mission now to make it more acceptable color. As you can see, I implemented a permission check class with the simplest implementation, then make my test green. Let's implement second test. So I'm switching to branch number 4, and it has the same context, but the different second input and expectations. Now, if resource is specified, look at this lambda, then no warning should be added. Here how code looks like. Switching to the next branch. And here I made it work. At first, I found out, is it a policy at all? And if it is, then check is a resource is a star. If it is, then add a warning. And here we go, it's green. Switching to a new branch. I noticed I never checked for deny. Let's make deny test. I am not going to isolate deny in its own context, because in this case, only one test is required. Here we go, input and deny permission with a star as resource, and check there isn't any warnings. Implement it, and now, here's the implementation, and now we're going to go green. In this demo, I explored a little bit more advanced concept with aspects. So I gradually built my story using unit tests. Did you notice? I have never deployed any resources in AWS environment, and all evaluations have been made locally in memory. I instantly knew when something wrong and was able to locate the problem and intended expectations. There are a few frequently asking questions. First, I have too many tests. Sometimes it happens, and often it's okay. But you need to make sure each test has a domain expectation and not the code line. The second concern is that each change breaks a lot of tests and actually slows you down. Try not to think about implementation when you write code. Consider implementation unknown until you actually start coding it. When your tests are going to be less specific to implementation and bring in more business value. And my favorite one, it takes so much time. And it is true. According with the Microsoft white paper, The initial development may take up to 35% more time. And if you think about coding as an independent activity, it is a significant drawback. But if you think about software delivery lifecycle as a whole and risks and overheads associated with it, you probably find that having less bugs very positively affect not only the speed of the delivery, but also developers' mental health. Nobody likes to fix defects. If you need to know more, please check CDK Developer Guide and API docs. It contains all information you need to start. You can practice CDK using our workshop tutorials. There is a link to this Microsoft and IBM white paper I mentioned a few slides before. And if you want to know more about TDD, or you have problems with it, the original test-driven development book is available in Amazon and has most of the answers. I highly recommend to read it. The technique I demonstrated today is a process. And as any process, it can be busted. It is going to be awkward and uncomfortable at the beginning. You would want to do implementation and do not write the stupid tests. Soon, you would notice a difference. Your components become more testable and reusable. Getting back to code you wrote a year ago will be easy. I put kata here, and those who practice TDD already familiar with this term. It came from Japan. It means you select a movement and then work on it till perfection. So I recommend to do so. Select a problem and work your way through multiple times. Look for different solutions. At some point, you will look back and see how your skills improved. Join the CDK community. It is way more fun to go together. You join AWS Summit to learn. And you can keep learning beyond the summit with resources from AWS training and certification for DevOps. We offer over 45 online digital training that is available on demand. You can go deeper with the 3-day instructor-led course, DevOps Engineering on AWS. You can gain credibility and confidence with tool-related certifications. You can also explore labs, white papers, and other technical resources by downloading the AWS ramp-up guides. For the more information, visit aws.training/DevOps. I talked today a lot about how to use CDK. But if you want to know more about why to use CDK and hear real customer story, please check Empowering Your Development Teams with CDK for Speed and Safety with Shri. It was Nelly Lovchikova with you. Please enjoy coding. And I hope if you get to this point, you at least have some feelings toward the topic, or me personally. Please go to the survey link provided and write it down. I desperately need your attention.